Perfect. Okay, so we talked about binary, we talked about hex. Like these are pretty basic, pretty boring subjects in general, but important. The last kind of more conceptual thing I want to talk about before we actually like really start talking about the internet and get into like things you can do, code and stuff like that, is the idea of storage versus compute. Now on our tree, this this requires like binary and hexadecimal, just a little bit of understanding like conceptually of what they are so that you don't get like confused along the way. But basically, we're going to talk about computation or compute plus storage. So let's get started with that. All right, compute and storage. So the reason I'm bringing this up is because it's kind of important that you understand how devices that can compute, um, like you have to understand the basic principles of what's within them and what's going on inside of them, just so that like there's no magic, because there really isn't any magic anywhere in tech. It's all basically the same thing happening over and over again, billions of times per second. So so when I talk about compute and storage, what I'm really talking about is the devices that you use day to day. So like a computer, for example, with a desktop computer with a keyboard, or a laptop is good. I'm not gonna draw the whole keyboard. Um, a cell phone, right? Like your cell phone is a computer. Your a remote control, like for the TV, is a computer. I don't know how that's a remote, but like that's supposed to be a remote. Any like sensor you can think of, like if you have plants or something like that, and you have like a little sensor between them that tests the humidity. I don't know. Like the only way that these like electronic devices can work is on the same basic principles, and what is contained within them at various different levels of power and various different levels of kind of like quality is compute and storage. And so I'm going to break down these two concepts for you just to give you a good idea. So let's pretend that we're talking about a desktop computer specifically. And I'll draw a box here. This is my desktop computer. Now, remember that in different kind of shapes, this is true for all of the devices I've talked about, but I think the desktop computer is the easiest to conceptually understand. Um, in the desktop computer, you have a section of its hardware, and we're still talking about like physical hardware at this point, that is storage. And at the end of the day, all storage is a series of boxes, right? That contain binary. So you got boxes here, and you can imagine that inside each of these boxes there is binary. Now, in general, in storage situations, the amount of bits inside each of those boxes is going to be the same. So, what do I mean by a bit? Now, whenever you write down a binary number, let's say I write down this number here. I don't know what the number is, but it's a binary number. Each single one of these is called a bit. And a group of 8 bits is called a byte. And I'm not going to go through how, but like kilobyte, megabyte, etc. is just like kilobyte is 1,000 bytes, a megabyte is 1,000 kilobytes, a gigabyte is 1,000 megabytes, etc., etc. Um, Normally in storage, no, not normally, definitely always in storage, the amount of bits that each box is able to hold is fixed. So it's going to be something like 32-bit, for example, or 64-bit, or 8-bit even. And the reason that this detail is important is because every single one of these boxes inside of storage has a address, and that address is normally written down in hexadecimal. So let's say this is the what like the let's say that's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th um box in my storage. I might write its address like this, and I might say this is the 10th, which is A, storage box. So the reason I'm going through this and the reason I'm like going into so much detail is because you can't really have computation. You can't really like do anything with a computer without storage. There has to be storage somewhere. And there are different kinds of storage. I'm not going to go through them. It's not really that important. But the data that is running through your system has to be stored somewhere so that the CPU can actually work on it, right? So that's the storage part. But now we're going to talk about compute. So there is a device inside your computer called a CPU. And a CPU is the computation processing unit. Computation processing unit. Processing unit. God, it's taking me a long time to write. There we are. And what the computation processing unit can do is it can take the binary that is in storage and it can do stuff to it and then put it back in storage, right? So I'll make a box here. Let's say this is the CPU. Inside your computer, it's going to be wired up to storage somehow. And the details of how that is, I don't even know, but it doesn't really matter. The point is there is a physical connection between the CPU and storage. And I don't know if you remember from the binary talk, but we said that binary is able to be represented in electricity, right? And that's because electricity has a voltage. Electricity has a voltage. And that voltage can be modulated, right? Or not modulated, changed. That voltage can be changed. So it's possible by like doing electrical things to have a wire be at a low voltage or to be at a high voltage, depending on how much energy is going through that wire. That's important because that means that we can represent zeros as low voltage and ones as high voltage inside our system, and we can transport binary around. So if we take a look back at my model on the side, on the left-hand side there with the storage and the CPU, what compute is, what basically happens is the CPU is given an instruction, okay? And that instruction that the CPU is given might be something like add 4 to 0x ... 1, right? Which means add, well, actually, I won't put 4. Let's put it in binary because we know binary now. Add, what's 4 in binary? This is 4 in binary. Add 100 to this. And what will happen is that over the wire, the CPU will get the stuff. Let's say this is 0x ... 1. Let's say that's the address of this box. What will happen is the CPU will grab the data that is in here and it will take it up. It will have this hard-coded value that it got from its instruction. It will perform the transformation, which will change those, will change the order of the ones and zeros by doing math to it and then making it binary again. And then it will put it back into storage, right? And that's really it. This interaction between the thing that does the computation and the storage is occurring in every single device that you have that can do compute at all, that can compute things, that can like any kind of technology that's using computation. So the reason that I'm bringing this up, this is super important, is because this is going to help us understand how the internet is able to function, how data is able to jump from one node to another, and survive basically, and survive, get to the place it needs to go, get the data back, send messages, whatever. So if there's one thing I can have you take away from this, it's that no matter what, if technology is occurring, there is some compute somewhere as a physical device, a CPU, and there's some storage somewhere, and they are connected by wires. That's it.